Good morning, everyone. The Siemens Center of Excellence in GC Bhavnagar, established in 2016 at Civil Department, operates with primarily focus of creating a robust technical education ecosystem through its experience and industrial products and services. Process Instrumentation Lab is a part of Siemens Center of Excellence Lab, which includes various sensors with their transmitters and related software. The major components of a control system include a sensor, for example, temperature, pressure, flow, or level sensor, a controller, for example, the PLC, and a final control element, for example, positioner, motor, or a switch. Sensor transmitters are primarily used to produce an output with a higher transmission range than the sensor itself can provide. For example, a sensor which outputs a small voltage or resistance value has a short range due to losses inherent in transmission wires. Range is the difference between the low and high values to be measured. This is always dependent on the physical sensor's range or calibrated range. Span is the difference between the range values. For example, a temperature sensor with 5 to 10 volt output may be calibrated to measure values between 800 degrees Celsius and 1200 degrees Celsius. Its range therefore would be 800 degrees Celsius to 1200 degrees Celsius. Its span would be 400 degrees Celsius and its zero would be 800 degrees Celsius. A smart transmitter is a digital device that converts the analog information from a sensor into digital information, allowing the device to simultaneously send and receive information and transmit more than a single value. Resistance temperature detectors (RTD). A commonly used temperature sensor is the resistance temperature detector (RTD), also known as resistance thermometer. Unlike field system thermometers, the RTD provides an electrical means of temperature measurement, thus making it more convenient for use with a computerized system. An RTD utilizes the relationship between electrical resistance and temperature, which may either be linear or non-linear. RTD are traditionally used for their high accuracy and precision. However, at higher temperature above 700 degrees Celsius, they become very inaccurate due to the degradation of the output sheet, which contains the thermometer. Therefore, RTD usage is preferred at lower temperature ranges where they are the most accurate. A schematic diagram of a typical RTD is shown in figure. As shown in the figure, the RTD contains an outer sheath to prevent contamination from surrounding medium. The resistance sensor itself is responsible for the temperature measurement as shown in the diagram. Sensors are most commonly composed of metals such as platinum, nickel or copper. The material chosen for the sensor determines the range of temperature in most the RTD could be used. For example, platinum sensors, the most common type of resistor, have a range of approximately minus 200 degrees Celsius to 800 degrees Celsius. Connected to the sensors are two insulated connecting leads. These leads continue to complete the resistor circuit. This is RTD, which is PT100, and its range is minus 200 degrees Celsius to 850 degrees Celsius. This RTD is connected to its transmitter, and the data from this transmitter is taken via 250 ohm resistor, and from this 250 ohm resistor whatever data is collected, that data is connected to the computer via HART modem. The other part of the HART modem is connected to the USB port. In this computer, we have a software called Schematic PDM, Using this semantic PDM software, we can check out the amount of temperature changes, amount of equivalent resistance change, and voltage change. So the semantic PDM software is opened. Now to check the various parameters of the RTD, let's go in the file menu and let's create a new file and give some name as like th300_1, because the transmitter used in RTD PT100 is th300. And OK. So here we have created a file called th300, and this is known as process device network view. So now let's right click on it and go for the insert new object and networks. So a network is created here. So by right clicking on the network, again we will have a new object which is a communication network. Now here you have a block called its insert object networks, and in the object name we'll go for the assign device type. In assign device type, we'll go for the network. As we have used the heart modem, we will use heart, and in that heart modem network. Okay. So here the object name has automatically come there. Now to check the connection number, now we'll have to check the connection number, because in our computer we have many USB ports. So at which USB port we have connected the heart modem, to check that out, I will go in the my computer. In my computer, right click on the manage. After that, device manager. So in device manager, we have different types of ports here, and here it is Viator USB heart interface. Now you can see here at which port we have connected it, and that port is 5th. So we have just find out that at which communication port our HART modem is connected. Now let's again move towards our schematic PDM software. In schematic PDM software, here we have a computer name. This is our name of the computer, which is DT_COE_DWS067. When we are going to open it, it gives us the COM port interface, and in COM port interface, these are the properties of COM port interface. And here in a COM port, here in COM port, the COM port is number 5, so I will just type 5 over here. And OK. Then in HART modem network, right click on it, insert new object and object. In insert object, assign device type. We are not going to write the name here. We are just using the assign device type. And in assign device type, we have a sensor connected to it. Go for the sensor. We have a temperature sensor. And in temperature sensor, now in HART modem network, right clicking on it, we will go for the insert new object and one object. It will create the menu of insert object, which is the HART modem network. And we will go for the assign device type. In assign device type, in HART, the device identification we will have to do. So we are not going to choose the sensor over here. We'll just go for the device identification, so that whatever the sensor is connected through the HART modem, that will be appear over here, which is Citrans TH300. I will provide the OK. So it is selected already there. And OK. So Citrans TH300 is now in our file. So let's right click on Citrans TH300 and we'll go for the open the object. We are going to open this object. So these are the device parameters of Citrans TH300. So various parameters are there: hardware name, its version, distributor. So you can see here the lower limit is -200 degrees Celsius and upper limit is 850 degrees Celsius, and minimum measuring span is 10. The unit is degree Celsius. So if you want to check out, if you want to put the limits to these values, you can just give the lower limit as well as the upper limit. The type of the sensor is resistance thermometer. and it is PT100 and it's a 3-wire sensor. Now to check out various parameters of TH300, we are going to upload to PGPC. So here in the menu, so now we will do for the upload to PGPC. Now we are going to upload it, so we'll start the process of uploading this data to the PC. So the device is RTD and close. Now to check it out, in Citran TH300, we want to check out the process variables. So this is the process variable tab. So it shows the different values of RTD. Now right now this RTD process variable is online. Measured value right now it is 21.34 degrees Celsius. परसेंटेज इज़ 38.9, जो हमने रेंज दी है उसमें उसका जो परसेंटेज है इट इज़ 38.9 एंड इट्स एनालॉग आउटपुट इन मिली एम्पियर इज़ 10.214. So now let me give some heat to the RTD and just check out that what are the change in the measured value. So you can see here the measured value ranges up to 26.42 degrees Celsius. And now it will be back to its original value. Let's check what is there in the trend view. So in a trend view, you can have a graph of how the value of temperature changes at different time scale. So here at this time scale, I have the value of temperature which is moving somewhat like this. So again I am providing some heat to the RTD and let's check out what happens in this trend view. C. For specific amount of time, the temperature of the RTD is raised and again it will fall to its original value. If you want to give some minimum and maximum values and you want to show on the scale that whether it has crossed the temperature limit to minimum or the maximum value, you can set the values over here.